Alright, here we're going to work through the Chapter 9 review, starting off with graphing quadratics. So what we're going to do is talk about the key components of each of these, and I'll label them off here to the side for the first one. The axis of symmetry is the dotted line that passes through any quadratic, whether they open up or down. You'll have a dotted axis of symmetry. It's always an x is equal to line because it's vertical. And it comes from the formula that helps us find the x-coordinate of the vertex, because the axis of symmetry has to pass through the x-coordinate of the vertex. Which means for this one, we're going to start off by doing negative b over 2a, to where a is 3, b is 6, and c is our negative 3. So negative b over 2a is going to give us negative 6 over 6, which gives us an axis of symmetry of x is equal to negative 1. It also tells us that the x-coordinate for our vertex is negative 1. So then what we'll need to do, and this is true for any time we have an x-coordinate and we're looking for a y, we need to plug that x-coordinate back in to the original equation. So in this case, we're plugging in negative 1. So we'll get negative 1 squared to get a positive 1. So we have a 3 minus 6 minus 3 to get that our y-coordinate is equal to a negative 6. So now we know our vertex is that negative 1, negative 6. Y-intercept is always 0, comma, c value. So in this case, 0, comma, negative 3. So we know some points for this now. When it says other points, we need to make a table. And when we make a table, it's important to put the vertex right in the middle. So that would be negative 1, negative 6. And the reason that we want the vertex in the middle is so that these points are the same and these points are the same, because the vertex is that axis of symmetry. It makes both sides symmetrical. So to continue the table, we'll count down and we'll count up. Now, 0, comma, negative 3 is the y-intercept, right? We talked about that right here. So that's going to save me having to plug some values in to find other points, because we already know the y-intercept is negative 3. And then because of symmetry, it reflects across to the other side. Now what we'll do is we have to pick either negative 3 or positive 1 to plug back into the equation. I'm going to plug in 1 because it's easier. And when we do that, we get a 3 plus a 6 minus a 3 to get that y is equal to 6. We now have enough points to make a solid graph here. I have my vertex at negative 1, negative 6. We have a y-intercept at negative 3, and then there's its symmetrical point. And then it was at 1, comma 6 and negative 3, comma 6. And when you do this, you should notice that you get a nice symmetrical quadratic. If yours didn't turn out symmetrical, you've done something wrong, and that's a good visual cue to go back and double check your work. So let's talk about this one. Axis of symmetry is always negative b over 2a, but notice that this one has a b value of 0, right? And we know that because there's no regular x's. So when we go to do our formula, and our a in this case is an invisible negative 1, when we do our formula for the axis of symmetry, we get 0, because 0 divided by negative 2 is 0. So that means our vertex is centered at 0, comma something. We also know that y-intercepts are always 0, comma something. There's 0, comma c. In this case, our c value is 5, which means our vertex on this one is also 5. The vertex is obviously not always the y-intercept. The vertex on this one was not the y-intercept. But on this one it was because the b value was 0. which means when I go to make a table, I'm going to put my 0, 5 right here in the middle. And we're going to have to pick from these other points to plug in. So I'm going to need to plug in 2 values on this one. Now, one thing to notice that I put this negative sign on the outside. That is how you have to do it. This negative is an a value of -1. So there's really a -1 waiting after I square a number. And I'm going to choose to plug in +1. So +1 squared is 1, and then that -1 catches it. So this ends up being 4 for both of these. When I go to plug in 2 or -2, I'll plug in +2. We get 2 squared is 4. Then we get a -4 plus 5 to get 1. And we can now graph this. And you'll notice that once again it's symmetrical. And this one does open down, which shouldn't be a surprise because anytime there's a negative out front of the quadratic, anytime we see that negative, we know that our quadratic is going to be opening down. So let's do one more. Axis of symmetry is -b over 2a. Our b value is a -4, our a is a 1. So our axis of symmetry is 4 divided by 2 to get a 2. And that tells us that the x-coordinate of our vertex is 2. We can find the y-intercept by doing 0, c value, so 0, -1. And then now we can make a table. I need to put my vertex in the middle, but notice we don't know the y-coordinate for the vertex. So we're going to have to go back to the original equation and plug in our x-coordinate of 2. And when we do that, we'll get a 4 minus 9 to get that y is equal to -5. So there's our vertex. And then we'll count to make the other values on our table. So we know that these are the same and these are the same. We already know the 0's, -1 because it's our y-intercept, which means I'll have to plug in one value here into my equation, which would be either 1 or 3. I'll plug in 1 because it's smaller. And we'll get a 1 minus a 5 to get that y is a -4. And now we can come graph it. We have our vertex at 2, -5. And then we have 3, -4, as well as 1, -4. And then our y-intercept at -1 and 4, -1. Now once again, you'll recognize that you get a symmetric quadratic graph. Solving by factoring. When we're solving by factoring, remember we must equal 0. That way we can set up the two pieces equal to 0. So for this one here, it's the more difficult type of factoring. You could check for a GCF first, but you'll recognize that there's no way to divide both of those by 3, so we are stuck doing the more difficult type of factoring. So I'm now looking for numbers that multiply together to give me 20. One of them is going to be positive and one of them is going to be negative. And I need it to where when I FOIL it out, that the O and the I of FOIL add up together. So I need those to add up together to give me a -11x. You're now just thinking through some of the different combinations that are available. And when you check through enough, and you may miss some, you'll recognize that it's this combination. Because 3x times negative 5 is negative 15x. 4 times x is a 4x. Negative 15x plus 4x does give me a negative 11x. So that's the correct factorization. Now what we have to do is we have to take both pieces, set them up equal to 0, and solve. So we'll end up getting the answers of x is equal to 5 and x is equal to negative 4 over 3. For this one, we must be set up equal to 0 before we're able to factor, which means we need to add 32 to both sides. And when we do that, we'll have s squared plus 12s plus 32 is equal to 0. And this is the easier type of factoring, where it's going to start off s and s. I need factors of 32 that add to 12, and that would be 4 and 8. But remember, once you get it correctly factored, you must set it up equal to 0 and solve. And remember what solutions are is we're finding x-intercepts. Remember, solutions are x-intercepts. This one here, we need it set up equal to 0, so I'm going to subtract 7d from both sides. Now this one's a little different because it doesn't have a c value. And so what we'll have to do on this is just try it from greatest common factor. Both of those terms have a d to share. And now that's fully factored. We'll set up both pieces up equal to 0 and solve. So one of the answers is 7 and one of the answers is 0. And remember, all that we're doing here is we're finding answers that make this equation correct. So if I go through and I check both of these, so if I plug in 0, 0 squared is 0, 0 times 7 is 0, it checks out. And then if we also wanted to double check the answer of 7, we see that it is correct too. We'd get 49 is equal to 49. And it works for these too. If you plug back in these answers on the original equations, you get true statements. It also tells us that if I was to make a graph for this one, it would cross the x-axis at 0, and it would cross the x-axis at 7. We're now going to solve by completing this square. So the first step is to move C term. If it's there. It's not always there. On example number 1, the C term's already gone. Then step 2. What you'll want to do is you'll want to add b divided by 2 squared to both sides. And then that's going to allow you to then factor. And then the final step is you square root both sides. So on this one, step 1's been done for us. The C term is out of the way. I've got a blank spot here after the x. So what I'm trying to do is get this to factor to the same thing twice. And that's why we do b divided by 2 squared. Because when I do b divided by 2, it gives me a negative 4. Because b divided by 2 gives me a negative 4, so I'm going to put it into both of those slots. But b divided by 2 squared gives me a 16. So what we're really doing here is we are adding 16 onto both sides. And it allows us to get it factored to where x squared minus 8x plus 16 is now a perfect square, to where it can be x minus 4 squared. We're then ready for the final step, which is to square root both sides. And we'll get x minus 4 is equal to plus or minus 10. And remember that anytime we take a square root, we have to include the plus or minus with it, because 10 squared gives me 100, but so does negative 10. And then we'll set up both cases. X minus 4 is equal to positive 10. X minus 4 is equal to negative 10. So we'll get that x is equal to 14, and we'll get that x is equal to negative 6. So those are the two x-intercepts. Those are the two spots that equation would cross over the x-axis. Now, anytime you get whole numbers like this, that means we could have factored it, but completing the square helps us solve other ones where we cannot factor it, like 15. 14 we could have done by factoring because the answers were whole numbers. But one like 15, where c's already moved out of the way once again, this one has to be done by completing the square, and you'll see why when we find the answer. So for this one, I'm trying to find out what number needs to fill that spot to make it a perfect square. And that number is b divided by 2 squared. So we have 8. And it gives us a 16. So I'll add a 16 here, and I'll add a 16 here. The reason we do that is so that this left-hand side factors to v plus 4v plus 4. And if you're wondering, hey, is that 4 because there was a 4 inside that squared term? Yes. Is equal to 31. So this is v plus 4 squared is equal to 31. We'll square root both sides to get that v plus 4 is equal to the square root plus or minus of 31. And then when I subtract 4 from both sides, I'll get a negative 4 plus or minus square root of 31. That answer is a decimal. Factoring wouldn't be able to find us that answer. We needed completing the square to find it, or later quadratic formula, but completing the square finds it as well. So let's do one more, completing the square. And on this one, we are going to need to do step 1, which is making sure that we get rid of the c term so that we have space to work. Now, when I go to do b divided by 2 squared, we get a 9. So I'll add a 9 here, and I'll add a 9 here. And that allows us to factor to x plus 3, x plus 3. And that plus 3, once again, comes from just splitting that 6 up into 2 equal pieces. And it allows us to factor x squared plus 6x plus 9 into 2 identical pieces. We take those identical pieces and write it as a perfect square like that. And then we're ready to square root both sides. So we'll get plus or minus 8. And when I set up both of those scenarios, we'll get the answers of 5 and negative 11. So what that's telling us is that we could have factored this original expression. You know, it's the easy type, so it would have been x and x. And then the factors for this one would have been plus 11 minus 5, because 11 times negative 5 is negative 55, and 11 plus negative 5, 11x plus negative 5x gives me 6x. And then when you use the zero product property, you would realize that we get the exact same answers that we got by completing the square. And that's because completing the square is just another method to solve, which might make you wonder, well, then why do we do it? That's because sometimes you need it. Sometimes the only way to find the decimal answer is to complete the square, or use the quadratic formula, which we had also seen. But it's a little bit longer. We'll pick back up on the second part of this review in the next video.